Hi all, welcome back. Welcome back to one more assertion series. So in the previous session we have already given the introduction to assertions in system Verilog. If you didn't see that video, I'll link that in the description box. You can go there and check it out to know what are assertions, what is the need of assertions in system Verilog, what are its advantages, what are the types of assertions in system Verilog. Right, so in today's video we are going to talk about the types of system Verilog, which are immediate assertions and concurrent assertions. So we are going to talk about these two assertions in today's video, right? And before going to video, if you are new to this channel, consider subscribing this channel and hit on the notification bell also. This is the channel where you can learn about the courses related to design and verification domain like Verilog, system Verilog, and UVM, right? So now getting into today's video, which is immediate assertions. So in the previous video I have already talked about what is the difference between immediate assertions and concurrent assertions. So from the name itself you can see that when you are writing the assertion in an immediate assertion manner, then that can be easily checked at the current simulation time itself. That means the whenever you are writing the condition in case of immediate assertion, then that condition will be checked immediately in the current simulation time. Okay, so basically, as I already told you previously, immediate assertion is nothing but it is just a form of if else statement. Okay, so if you see here, this is the syntax of immediate assertion. Assert, okay, whatever expression you want to write, you can write. Like for example, you are writing as a and b. Okay, this is my expression, and the past statement, if it is not passed, then else fail. Okay, so this is how the assertion, you will be writing the assertion, which is called as immediate assertion. Okay, here if you see, if the expression is evaluated as true, then the past statement is executed. If the expression is not evaluated, then what happens, the fail statement will be shown. That means there is an assertion failure. Fail statement is shown is nothing but there is assertion failure. So assertion failure means then you can know at what point of time this particular signal is being failed. Okay, this is why we use assertions basically in order to reduce our debug time, because when you are designing the complex circuits, it is not easy for you to check each and every signal in order to know where the actual bug has occurred, which is why when you are writing assertions, then you can understand that, for example, if you are writing an assertion for these two signals a and b, and if there is an assertion failure, then you can immediately find, okay, there may be bug in either this or this signal. Okay, then you can limit your um, debugging time to only these two signals, which is why assertions are really important, right? Hope you got it. So if an assertion evaluates true, passed. If it is failed, then it is assertion failure. Okay, so if there is any assertion failure, basically past statements, if it is passed, then it will be executed, everything will be fine. If it is failed, then it will be showing you there is an assertion failure. Is it or not? So basically, when you are writing these fail statements, when you are building this assertion, now depending upon the failing statement severity, it is again, there are again four categories within the assertion failures. Okay, dollar fetter, dollar error, dollar warning, and dollar info. Okay, just like you will be seeing in your log file, you will be seeing dollar error, like you will be seeing sometimes errors, sometimes you will be seeing warnings. Okay, similarly sometimes you will be seeing the fatal errors. Okay, and sometimes you will be seeing the dollar info. So basically these are nothing but the severity levels of your error. If there is any runtime error, then it will be shown as dollar fatal or dollar error. Okay, if there is any just runtime warning, there is a, just if it is basically warning means it will be it can be suppressed by using some tool specific manners. Okay, and if there is any dollar info, basically if there are no nothing much specific about that particular error, okay, then basically it will be showing you in the format of dollar info. Okay, so this is how these are just the severity levels of the error that is caused during this um, immediate assertion, right? So this is about the immediate assertion. So let us see how we are going to write the assertion, immediate assertion. Okay, for example, if this is my particular code, okay, so here I am having clock A and B. These two are inputs, clock and A are inputs. Okay, now AB, for example, clock for every here if you have generated the clock, always hash 5 clock equal to negation of 5, negation of clock. That means now the clock period is total of 10 time units, right? Now initial begin, I am just passing the values to A and B. So A and B are 1 and 1, and then after 15 time seconds I have changed the value of B to 0. Since I didn't change the value of A, it will be 1 only, and after 10 time units it is 1, and I have changed the A to 0, and after 20 time units it is 1, and then after 10 time units I have completed my entire passing values and ended. Okay, now for this particular spec, if there is some rule for there is some condition that for every passage of clock assert A and B, that means for every positive, now if you are writing the assertion in this manner, what is the meaning of this? Always at the rate of passage of clock. That means for every passage of clock assert A and B. That means what happens if A and B both are 1, then this assertion occurs. That means assertion is passed. If A and B is not 1, then the assertion is failure. Okay, in order to know whether A and B signals are 1. Okay, because basically 1 and 1 means you will get the output as 1. Is it or not? And condition. So you don't want this to be failed. Like 1 and 1. You need the output as 1. So now what happens? If there is assertion, any assertion failure, then at that particular clock time you can just check that whether A has become 0 or B has become 0 instead of checking the entire clock cycles. Okay, now let us see here assert A and B. So if you see here, for every passage of clock the assertion checking will be done, right? So now if you see here, for every passage of clock A is 1, right? Here B is 1. So since A is 1, B is 1, assertion has passed. Fine. Now after this, again here this is negation of clock, so there won't be any checking done, assertion done. So again the assertion is checked here at passage of clock. Now at this passage of clock A is 1, but if you see here B is 0 because it is reduced, so the assertion is failed. Again next passage of clock it will be checking A is 1, but sorry, A is 0 but B is 1, but A is 0 and B is 1, so assertion is failed because assertion needs to be A and A both should be 1. Now again at passage of clock 0 1, so again assertion has failed. Okay, now at this point where A is 1 and B is 1, so assertion has passed. Now what happens? You have to check in these three clock cycles, because these three clock cycles you will be telling that assertion has failed. Okay, at 15 nanoseconds you have to check, at 25 nanoseconds you have to check, and at 35 nanoseconds. Now what happens? The debugging time has reduced from this entire clock cycle to these three clock cycles just by writing a single line which is an assertion. Okay, this is how the assertions are useful. So this is how you write an immediate assertion. Immediate assertion means just when you want to write a condition and at that particular current simulation time only the assertion will be checked. Okay, this is how you will be developing your immediate assertion. Now coming to concurrent assertions. Okay, so concurrent assertions means basically these assertions are evaluated over a period of time. Okay, like basically if, it will be taking multiple clock cycles in order to evaluate these concurrent assertions. So and you already know that like when we are talking about the SV regions, I have already told about this assertions. Okay, you can just check that SV regions like schedule semantics. Okay, I link that in the description box, or I link it in the title of this box. Okay, so you can title of this window, you can go there and check it out. There I have particularly mentioned that concurrent assertions are sampled in the preponed region and they will be executed or evaluated in the observed region. Is it or not? So these are the concurrent assertions that we are talking about. Basically, as I already told you, immediate assertions means they will be executed as soon in the active region itself, as immediate at a simulation time, at runtime itself they will be executed. But concurrent assertions are not like that. They are executed over a period of time. What is that period of time? That is, they are sampled in the preponed region and they are evaluated in the observed region. So it takes a period of time in order to evaluate these concurrent assertions. Okay, and also one important thing about this concurrent assertions is that concurrent assertion is evaluated only for every clock tick. Okay, so for every positive or negative that you are giving, they will be executed. Okay, so that is why we call this concurrent assertions are clock based evaluation model, because they will be executed only based on the clock. So that is why concurrent assertion is always tied to a clock definition, right? And as we already discussed, these are sampled in preponed and evaluated in the observed region. Okay, and if there is any pass or fail statements, they will be produced in the reactive region, right? So this is about the concurrent region. This is most frequently asked in interviews, like concurrent assertions where they are sampled and where they are evaluated and where the pass or fail statements will be executed, right? Now, concurrent assertions can be declared in, as you already know, assertions. In the previous session, I have told you, you can write assertions in both RTL as well as test bench. Similarly, you can declare these concurrent assertions in always blocks, initial blocks, and you can write it in either interface or program or module block, program block. In everywhere, you can insert these concurrent assertions. Okay, here in the immediate assertions we have already talked that when you want to assert is the keyword here. Okay, assert means what happens, the execution takes place, the execution of this assertion takes place by using the keyword assert. Similarly, in this particular concurrent assertion, you will be using the assert property is the keyword. Okay, you will be using assert property. So we will be discussing about what is this property and all in the upcoming sessions, right? So this is the assert keyword. Along with, if there is a assert keyword along with property, then you can declare that as concurrent assertion. This is how you can differentiate. Basically, just a simple what I can say tip for you. Generally, if you see as assert property, assert property, then that means it is a concurrent assertion. If there is no if there is only assert on the logic, then it is a immediate assertion. Clear? So this is how basically a tip in order to differentiate between immediate and concurrent assertion. Now let us see how, what is the syntax of this concurrent assertion, because as I already told you, concurrent assertion is executed over a period of time, and also in immediate assertion you are having only one, basically one logic or one sequence. But in concurrent assertion it is not like that. You will be having multiple sequences in case of concurrent assertion. So let us see how we are going to develop them, right? So if you see here, for example, you are having just only one logic. Okay, you are having only one condition. Logic is not, that is condition basically. Okay, so if you are having only one condition, then how we are going to do it? Assert property at the rate of passage of clock, request 1 or request 2. Now what happens, you are telling it as assert property, as I already told you, so it is a concurrent assertion. So what is the logic here, what is the condition here? For every positive edge of clock, either request 1 or request 2 should be high. Okay, so in this way, 0 0 1 1 1 0 0 1, at least, since it is OR, so at least request 1 or request 2 should be high. So this is how I am writing if there is only one condition. Okay, now what happens, for every of these three conditions, for every of these three things, the assertion will be passed. If both request 1 and request 0 are 0, then the assertion is failed. Okay, so this is the condition for this particular assertion. Okay, as I told you, if there is more than one condition, then how we are going to do it? What if it is a complex property? If this is only single line, if there is only single condition, then it is a basic property. If there are more number of properties, then what happens? That is called as complex property. Okay, before seeing what is this complex property and all, okay, let me give you a small introduction on what is this property and all in this concurrent assertion. So basically, in concurrent assertions, one is sequence and other is property. Okay, you have to remember these two things in this concurrent assertions. So what is the sequence and what is the property? So basically sequence is nothing but, okay, if you say, I'll just explain this with an example to you so that it will be clearly understood for you, like what is sequence and what is property and what is the difference between these two things. Okay, so if you see here, sequence and the name of the sequence, this can be any name. Okay, I'm just keeping this sequence name as request sequence, so this is the name of my sequence. Basically, when you are writing a assertion in concurrent assertions, how you will be write sequence and sequence name. So this is the syntax and the condition. So what is the condition here? Request signal hash hash 1 grant signal. What does that mean? So in this sequence, first defining that the request signal should be coming first. This is the first event. Okay, so after this event, then after one time unit of delay, that means after one clock cycle, the grant signal should be followed. Okay, so this is the meaning of this particular sequence. Okay, so in this sequence I am having two events, which is request signal and grant signal. Here, after request event is done, after one clock cycle, grant event should be followed by the request signal. Okay, and then the end sequence. Okay, so this is my sequence. Now what I am doing, okay, I am just, in order to, as I already told you, in concurrent assertion you will be asserting property. So what I am doing, I am making this property. What here in this concurrent assertion, you can have many number of sequences. So this is one sequence. In this way you can have two or three number of sequences also. Now in property, what you will be doing, you will be combining all these sequences and you will be writing the property, and then at a time you will be asserting property. So now what happens, instead of asserting all these sequences one by one, you are combining them in the property. Either if there is one signal or if one sequence or many number of sequences also, you will be making that as a property and then you will be asserting the property. Clear? This is the concurrent assertion. Now what happens? Property handshake. So at the rate of passage of clock, okay, request sequence and then grant signal. Now what happens? This is the implication operator. You will be seeing, I'll be explaining about what is this one, what is this one in the upcoming sessions. Don't worry about that. So now coming to this property handshake, what happens for every passage? So property handshake means this is also name. Okay, just like sequence and any name you like, and similarly property and any name. Okay, this property name is handshake. Now for every passage of clock, so this is my sequence. Request sequence should be followed by grant signal. Now what happens? So this is my sequence. Similarly, for example, if you are having two sequences, so this is my one first sequence, which is sequence request sequence. Similarly, I can have another sequence like request name. Okay, I'm having another condition here. Right now what happens, request, I can just write it as request sequence should be followed with name sequence. Okay, so now what happens, this logic will be followed by this logic. Clear? In this way you can combine all the sequences within the property and then end property. Just like you will be when you are writing a sequences, it should be starting with sequence and it should be ended with end sequence. Similarly for property, it should be followed by property keyword and end property. Okay, now what you are doing, you are writing the sequence and you are writing the property, and then you will be asserting the property. Asserting the property is nothing but execution of this particular assertion. Okay, so execute this particular handshake. Now what happens, this handshake is consisting of request sequence name. So inbuiltly what will be happening, this name and this request sequence will be asserted. That means the logics behind these two will be asserted. Clear? So this is the how you will be writing the concurrent assertion. So let me give, if you don't understand this particular thing, let me explain you much more easily in a theoretical way, so that when we will be explaining the code on this particular concurrent assertion in the upcoming sessions, you can easily understand. So as I told you, SV assertions of this concurrent assertions, basically when you are because immediate assertion means there will be basically only one sequence and it will be executed, but concurrent assertions, as I told you, is very important because immediate assertions there won't be. Basically, when you are writing assertions, you will be mostly using this concurrent assertions itself. Immediate assertions, basically when you are just writing some basic conditions only, you will be using that immediate assertions. So concurrent assertions are very important when it comes to assertions. So just before we have explained, right, in this I am just explaining the steps like how we are going to write a concurrent assertion. First you will be creating the boolean expression. Boolean expression is nothing but, for example, if you see here, okay, see, uh, at the rate of passage of clock a equal to 1, so this is my boolean expression. In this way, first you will be creating all the boolean expressions using the operators or using the yeah, you will be having events, multiple logical events. So using all these things, you will be creating the boolean expressions. Like boolean expression is nothing but basically depending on the, for example, if you want to check on these two signals, so what you'll do, you can use either and symbol or symbol, just we have done in the previous examples. Okay, first you will be creating the boolean expression. Now what happens after you have decided which boolean expression you have to apply on these two particular signals or something, then you will be creating the sequence for those expressions. So how do you create the sequence? By using the sequence and end sequence. So within the sequence you will be writing the name of the sequence and then the logic here. That means what happens here, you will be writing this particular logic, that is here, see, at the rate of passage of clock a equal to 1. So this is the sequence, this is the thing that will be here in this particular logic. Okay, so now what happens, in this way you can have either single sequence or many number of sequences. Okay, basically if there is only one sequence, then you will be writing only one sequence and ending. In this way, if you are having some two or three sequences, you will be writing two three sequences similarly in the manner. Okay, now what happens, now you will be creating the property. So creating the property means number of sequences can be combined logically or sequentially to create more complex sequences. Why is it? Because if there is only one single sequence, then it is fine. If there are two or three sequences, then it will become complex in nature. Is it or not? So now what happens, in order to make all those complex sequences in a easy manner, you will be combining all these complex sequences in a property. So here you will be using property and end property in order to mention the property things. Here what you will be doing, all the, you will be using all the expressions or sequence expressions, or if you want to test which type of expression you want to test, you will be testing or writing all these expressions within this property. Now what happens, after creating the property, you will be asserting the property. Asserting the property is nothing but now it is verified. Okay, the property is the one that is verified during simulation. It has to be asserted to take effect during simulation. Clear? Okay, you will be using the assert keyword, assert property and property name. So this is the property name. That is what I have explained here. Okay, so these are the four things you have to do when you are writing a concurrent assertion. First you will be creating the boolean expression, you will be writing the sequence, and then you will be creating the property where you will be inserting the sequence expressions, and then you will be asserting where you will be asserting this particular property with this property name. Okay, clear? So this is how you will be using this properties. Okay, as I told you, you can have many number of sequences, many types of sequences. Like this is a equal to 1, this is one types of sequence, a or b. Okay, a hash to b. In this way you can have many number of sequences, right? And implication operators, right? And again in this overlapped implication operators, non overlapped implication operators. So we'll be seeing all this one by one in the upcoming sessions. So stay tuned for that. And if you like this video, please do like it and also share this to all the VLSA aspirants. That is all. Thank you.